Hi, MIT class for 2015. This is just going to be a quick rundown of the Wireshark Lab for the networking course. Since we can't do the exact examples that are in the assignment, I've just set up a little sample worksheet where we'll go through very similar problems. What we'll do is look up a few DNS records using NSLookup. We'll then download a large image as opposed to uploading, which is in the assignment. And then just as a different application, what we'll do is to send an email from an unrelated domain to the one that we're doing the NS lookups on. But where we look up the MX records, for example, that will be used when we actually send the email to this domain. For each of these three activities, we will capture this using Wireshark, and we can then inspect them and analyze what's going on in the background once that's done. Okay, so we'll start off by launching a terminal, and we need to start up Wireshark. I'm using Linux, but the process for running it on Windows and Mac OS is fairly similar. Where the differences will come in is how the interfaces are named depending on your operating system. So once you load up Wireshark, you'll see a page something like this. There'll be an interface list which shows you all the network cards. In my case, I've got a wired Ethernet connection, which might be called local area connection on Windows, or Ethernet if you're using Windows 8.1. WLAN 0, which is the wireless network card, and then a few others that I use on in a more sort of advanced role. So don't worry if you don't see these listed on yours. If you're using Mac OS, these things could be called either EN0 or EM0 or EM1 or anything along those lines. The important thing is just try and pick the icon that represents the way you're connected to the network. So I'm connected to the wired network. I'm going to use Eth0, and we'll just start that up. Now you'll notice there might be quite a bit of chatter in the background. That's just because the network's actually being used for other things. We'll filter all of this out once we get through the assignment. So what we're going to do is look for the web server, which is www.hstrauss.co.za, and we do this by just clear the screen, typing NSLookup at either the command prompt or at a terminal, and then we just type the domain name that we're looking for. So in this case, www.hstrauss.co.za. We see here that it actually asks the local name server. This will be my caching name server on my DSL router, for example. And because it's a caching name server, so it's not the authoritative name server, it will list this as a non-authoritative answer. And from this we get a canonical name or a CNAME record, which resolves, sorry about this, which resolves to the main host name, which is hstrauss.co.za. This record itself resolves to two A records, which are given by these IPv4 addresses. So 185.35.77.77 and 197.96.137.155. So if, for example, I were to do an NS lookup for hstrauss.co.za without the www, I'd get the same last four lines. If I want to query a specific server, I could use, for example, Google's DNS servers, which are 8.8.8.8. I can just append that to the end of the line, and we'll see now that the server used is the Google DNS server. After the hash sign, we see there's also a number that indicates the port that's being used for domain queries. Alternatively, we could look up records that are not A records or quad A records in the case of IPv6. To do that, we just specify a command line option. We say -type equals ns, and that will now give me ns records for this, or at least should. Let's just prepend this instead of appending it. We now see that the results are name server records as opposed to host records. What it does, however, is to look up these host names and return their IP addresses as well. In this case, these hosts also have IPv6 addresses, so we'll get what we call quad A records, because there's four A's in the name, so we just call them quad A's. The alternative to adding the command line options is just to run it in what we call interactive mode. In order to do this, we just type nslookup with no parameters, and you'll see that we get this little greater than sign prompt. So once we're here, we can do something like set type equals mx, and we can then look up hstrauss.co.za. And you see now, instead of returning A records, or in fact name server records, what we get back are mail exchanger records. These are slightly different from the others in that there's a number prepending it, the host name, but that's just the nature of the MX record itself. It requires a number before the host name to specify an order of precedence. As you'll see, this one again is coming from my local DNS server, and therefore it's a non-authoritative answer. I'm just going to try to set server equals the authoritative name server, and it doesn't seem to like that very much. So what we can do is just exit from this and run the same query but from the command line and say type equals mx, and we're looking up hstrauss.co.za. What we'll do is to look that up against ns1.hstrauss.co.za. And as we see here, it now no longer says non-authoritative answer. It actually gives the exact records for the name server, and this one's actually going over IPv6. Chances are you won't see this in your home lab or even on campus, since native IPv6 is not really something that's widely available on the internet. But most importantly, the authoritative answer is actually the same as the cached answer at home on the DNS server here. So this record hasn't changed in the last while. That's what we can basically determine from that. Alternative to specifying the host name of the server there, we could also just specify its IP address. So that is 69.164.209.63, if I'm not mistaken. There. So this will now look up MX records for that, or TXT records for that, if that's what we desire to look up. So yeah, we've basically covered all of those there. We'll just stop the Wireshark because we've been capturing for quite a while now. There's about 900 packets that have been captured. We'll just stop that and save that as an exported list of packets. So here we'll just call this MIT'15 part 1, and we'll compress that and save it. You'll see it adds the .pcapng.gz extension to this, but we'd be able to have a look at this a bit later. So now we'll close this one and start a new Wireshark trace. So we're capturing again. This time we're going to download an image from the web server using this URL. So I'm just going to copy that and load up Firefox. So I'll just paste that into here. We'll download this file, and once this has stopped downloading, we'll just stop Wireshark again. So you see it's got 85 packets. And rather interestingly, I think it's using a different interface. Let me just have a look at this. Okay, we'll just start a new capture. We can we could just clear this actually, just to get a little less noise in the system, and we'll force a refresh, so this has been requested from the server again, and that is complete. And this is definitely not using that interface. Okay. Cool, we'll stop this. I've disabled the wireless interface, so we stop the trace. In fact, let's just go ahead and quit Wireshark for now. Quit without saving, and we'll relaunch Wireshark. Okay, so we start the trace on F0 this time. We're just going to refresh this image, and you see it's still busy downloading. And that is complete, so we now stop the capture. Yeah, this one's a bit more interesting than your standard one, since this is using IPv6. Let me just disable that. And then I will retake this as part 2.